Alright guys, this is part 2 of lesson 2.8 where we're going to look at 2 more strategies that can help us with the standard algorithm. So looking at a problem, we're going to go ahead and what this tip or trick says is that whenever you're multiplying by numbers that have zeros in them, you can utilize what you know about those placeholder zeros to kind of shorten your work. So let's look at this problem. 473 times 407. And I'm going to solve it twice, but I'm going to show you the second time we're going to do something a little different. So the first time I'm going to solve it straight through standard algorithm, nothing different. So really quick, starting on that right side, 7 times 3. Using that distributive property, 21. 7 times 7 is 49, plus 2 is 51. 7 times 4 is 28, plus 5. It's going to give me 33. Check my math there too if you need to. Alright, moving on. We're going to mark out we're done with the 7. We're going to move on to our next place value. So I got to put a placeholder there because I'm in my tens place now. Now I'm going to multiply by 0. 0 times 3 is 0. 0 times 7, 0. 0 times 4 is 0. Remember, 0 times anything is a big fat 0. Okay, moving on to that next place value. So got to put my placeholder there because I'm now in the hundreds place. So I get 1 for the ones place, 1 for the tens place. All right, working in my hundreds place. 4 times 3 is 12. Carry my 1. Ignore that 2 there. 4 times 7, 28. Plus 1, 29. Carry my 2. 4 times 4 is 16. Plus 2 is 18. Now add all my numbers here. Check my math here, make sure I don't do any addition wrong, but really when I do this problem again, I should end up with the same thing. So like we said in lesson 2.7, however many digits you have in your second number is however many lines of addition you'll need. That is true, but, so see 3 numbers, 3 lines of addition, perfect. But when we have zeros in that second number, we can use what we know about placeholder zeros, and we can utilize those to our advantage. So let's show that on this second problem. So I'm going to start out the same because I'm not working with a 0 yet. So 7 times 3 is 21. 7 times 7, 49. Plus that 2 is 51. 7 times 4 is 28. Plus that 5 is 33. So I get the same number starting out. Perfect. I should end up with the same answer. Okay, so I'm done with that 7. Move on to my 0. Okay, but I know, looking at this second problem, that 0 added nothing. So if I look back to my first problem, that 0 did nothing. It didn't change my answer or anything. It was just a straight line of zeros. So I know that 0 is going to equal 0. So for that tens place, I'm just going to go ahead and give it that placeholder because I'll just end up with a straight line of zeros. Now I can move straight on to my hundreds place, and I've got 2 placeholders already, and I'm going to multiply. 4 times 3 is 12, so carry my 1, ignore that other 2. 4 times 7 is 28, plus 1 is 29. 4 times 4 is 16, plus 2 is 18. So see, I have the same numbers here and here and here and here, but I just don't have that line of zeros anymore, which is really nice. So I cut down on some of the work. So when I add, I should still get the same answer. 192,511. 192,511. Pretty big numbers. Okay, so another thing to remember with this one really quick is because we can multiply in any order, if you're given a problem that looks like this, let's say 3,070 times 1,246, Okay. Because we can multiply in any order, notice that this 3070 has 2 zeros in it. That's 2 steps of the problem you can just kind of ixnay, get rid of, if you move it to the second number. So I can rewrite my math problem like this, because multiplication is commutative, and I'll know that I won't have to do any work on this 0 or this 0. So really the only multiply I'm doing is that 3 and the 3000 and the 7 and the 70. Pretty cool. So really can cut down on some work when you get in those larger digits. Okay, and then the last one that we're going to look at, our last tip or trick for using the standard algorithm. This is going to be just helping us to keep track of our work. Make sure that we are keeping up with that, so I'm going to erase all this for us. So our last tip is, because the standard algorithm has many steps, especially as you get into larger numbers, it's important to check your answer to each problem at the end. So some possible ways to check include using estimation, switching the order of the factors and multiplying a second time, using a number sense strategy, repeating the same problem, or walking through each step a second time to double check. So let's look at an answer, because I know that was a mouthful. So first of all, this is our fourth strategy. So if I have the problem 3022 times 71. I'm working through it. I know I'm going to have at least 2 lines of addition with my products at the end. So I can go ahead and start already thinking about this problem. Okay, this is kind of like 3000 times 70. And I know that 3 times 7 is 21. So 3000 times 70 is going to have 21 and some zeros, right? 4 zeros to be exact. So has to probably be, our answer should be around that number. So let's check that. Our answer should be around 210,000. Because I was just thinking, I'll show you my thinking here, that 3022 is about 3,000, and 71 is about 70. And I know that 3 times 7 is 21, and then I just have to add my zeros, so that's 1, 2, 3, 4. 1, 2, 3, 4. So my final answer should be about 210,000, roughly. Again, it's going to be a little different than that, but still should be in that ballpark. So I'm going to multiply out really, really fast here, starting on my ones place. 1 times 2 using that distributive property. 2, 2, 0, 3. That's also our identity property here, because 1 times anything is itself. Okay, we're done with that one. Moving on to our second place value here. Got to keep our placeholder. 7 times 2 is 14. 7 times 2 is 14 plus 1 is 15. 7 times 0 is 0 plus 1 is 1. 7 times 3 is 21. Now I can add 2, 6, 5, 4, and 21. So 214,562, pretty close to 210,000. So you can also do the problem again and check your work to make sure it's correct. But really what this strategy is showing is just make sure that you check as you do your work. Especially because once you get going and those numbers get really large, if you have to start a problem all the way over because you haven't been checking throughout, then it's going to be really hard to find out where you messed up, and going to take you more work in the end.